Hello, greetings to you. I want to use this opportunity to appreciate God for adding one more here to me. I'm plus one today. I want to also use the opportunity to thank you all for sticking to the Engineer Construction Lecture Hub. Today we are going to look at a very important topic as regards to construction. Alright, so today's topic is development of flexural cracks. Now, flexural cracks are usually emanates, on our horizontal components. All right, because when we talk about flexural members, basically we are looking at the slabs and the beams. All right, but our emphasis today is centered on the slab. Now, I talked about when the tensile stress is exceeded, okay, in our slabs, it usually leads to development of cracks. Okay, so when we have our slab, okay, let's say we have our slab in this manner. Okay, we have our reinforcements. Okay, so when we cut this section, well, maybe we cut section XX. Okay, we are supposed to have something like this. Okay, something like this. Okay, so our distribution bars runs. Okay, our distribution bar runs in this manner. Okay, so when you have a beam in this manner, it's expected that from half of this reinforcement, okay, to this part is what we refer to as D, the effective depth of slab. The effective depth of slab. Okay, y from this point to this point is our h. H is the overall depth of slab. All right, now I want you to understand that at this point to this point, that is the overall thickness of our slab. All right, but inside of this slab there is reinforcement. Okay, now you must understand the position of those reinforcements. All right, now I want you to also understand that from this point to this outer point is our D prime. Okay, so usually at this point, okay, in a continuous, let's say a slab. All right, okay, let's say a simply supported slab. Now usually moment is at the midspan. Okay, moment is at the midspan. Now once it is this reinforcement, this bottom reinforcement, that is what takes care of tensile stresses. Because once this load comes on the structure, all right, the load tends to stress the main bar, the bottom bar, because in case of a one-way spanning slab, it is the bottom bar that usually transfers the load to the supporting beams. So usually those bottom reinforcements are usually stressed, and that is what we refer to as tensile stress or tensile stresses. Now when these tensile stresses exceeds the capacity of this bottom bar, definitely there will be formation of cracks. And flexural members are expected to, once load comes on it goes this way. Okay, it goes this way. All right, once load comes on it, actually this is how each shape turn becomes. All right, because of the load. So usually this is the neutral axis. okay, and this point is usually in compression. All right, is usually in compression. Now this side is usually in tension. All right, so in slabs we see that as the load comes and the main bar now is this. Okay, okay, once this main bar is stretched, all right, because once load comes on this beam, on this slab rather, you see that this top part, the compressive zone, will tend to contract. Okay, to tend to contract, while this bottom part, which is the zone, the tension zone, tends to, you know, increase in length. That is tension, is in tension. So the load now causes tensile stresses to this bottom reinforcement. So the essence of we designing our slab basically is to come up with reinforcements that can be able to overcome the tensile stresses that this slab will be subjected to. Okay, so if peradventure the stress exceeds the tensile strength of this reinforcement, or the provision for the capacity of this bottom reinforcement, it means that definitely there will be formation of cracks. Okay, so that is why you see some slabs, you know, you see cracks, formation of cracks all over. All right, such slab now has developed defect. Okay, structural defect. All right, so I deem it necessary to bring this so that we can be able to understand these crack formations in our slabs. All right, and I want you to also understand that in our slab, you see that the reinforcements are placed. Okay, you have to deduct half of the diameter of your bar. Okay, you have to deduct the concrete cover. Okay, that's it. You have to deduct both to get, then you minus it from the overall height. That will give you the effective depth of our slab. All right, so a lot happens at this zone. Okay, this section. All right, a lot happens at this section of our slab, and that is where the strength of the slab lies. Okay, so basically this is how these tensile stresses, if they are exceeded, they tend to develop cracks in our slab. All right, so I'm going to stop here for today. Once more, happy birthday to me, and continually stick to the Engineer Construction Lecture Hub. More updates, more insightful content will be coming your way. Thank you very much, and God bless you. Bye.